Hello friends, let's learn a few quick things about motor unit. Let's have a diagrammatic representation. Here is a nerve trunk which has nerve fibers, the motor neurons which are reaching a skeletal muscle. So let's show these motor neurons inside a nerve trunk. This is nerve trunk. These are the three motor neurons which are innervating a skeletal muscle. Now this motor neuron has its branches. This axon has 3 branches as shown there. Another motor neuron, its axon has got 3 branches, and a third one which has got, let's say, 2 branches, and they supply the muscle fibers. Let's show the muscle fibers. 1, 2, 3. Then 1, 2, 3 and 1 and 2. So we have this entire muscle here. This is the entire muscle which has got these muscle fibers 3, 3, 2. Let's say 8 muscle fibers. But they are grouped into motor units. And now I am going to define the motor unit. Motor unit is a single motor neuron, its branches, and all the muscle fibers supplied by it. Well, again, a motor neuron means its axon, we are saying the axon, the nerve fiber, its branches, and all the muscle fibers supplied by them. That constitutes a motor unit. So we can see here there are 3 motor units, 1, 2 and 3. This motor unit number 1 has got 3 muscle fibers supplied. Then motor unit number 2 has 3 muscle fibers, and motor unit number 3 has got 2 muscle fibers. So in this entire skeletal muscle, and this is just diagrammatic representation, just for the explanation purpose, this entire muscle has got 8 muscle fibers in it, and they are grouped in these motor units. Let's define once again. A single motor unit means a motor neuron means its axon, its branches, and all the muscle fibers innervated by it, right? So there are 3 motor units we can see here. Now, why is it important to understand this? It's because, now listen to this part carefully. I'm going to tell you 2 important things about the motor unit. Whenever a muscle is contracting, at least one motor unit will be contracting. At least one motor unit. Okay. So it means what? It means, let's say we need a minimal muscle contraction. Then let's say this motor neuron will send the signal, and these 3 muscle fibers will contract in that particular muscle. Minimal contraction. Now, when we want to increase the strength of contraction, even this motor unit will start firing. I mean, impulses will be sent by this motor neuron, and even these 3 muscle fibers will be recruited in the muscle contraction. So 3 plus 3, 6 muscle fibers contracting. We want strongest possible contraction for that particular muscle. Then even motor unit number 3 will start firing. This axon number 3 will excite these 2 muscle fibers. So all the 8 muscle fibers in this muscle will start contracting. That will be the maximum possible muscle contraction, maximum strength of contraction for this particular muscle. Now coming to the real matter of the fact, or fact of the matter, let's say. A motor unit obeys all or none law, but the entire muscle does not obey all or none law. Right? That's the first thing that I need to tell you. a single motor unit obeys all or none law. Means either all the fibers in that motor unit will be contracting or no fiber will be contracting. As we saw, when minimal contraction was required, only this first motor unit was contracting. The other two motor units were relaxed. They were not contracting. But that means all the fibers in motor unit number 1 were contracting and other two motor units were not contracting at all. So a single motor unit obeys all or none principle. Means all the muscle fibers in that particular motor unit will be contracting together, or they won't be contracting at all. As we saw, minimal contraction, one motor unit was contracting, the other two were not contracting at all. No fibers in those motor units were contracting at all. But the entire skeletal, motor unit obeys all or none law, but the entire skeletal muscle does not obey all or none law. What does that mean? It means when you want lesser strength of contraction, one motor unit was contracting, but you went for a stronger muscle contraction, more and more motor units were recruited. So it's not as if zero or full in the case of the entire skeletal muscle. There may be one or two motor units contracting or three motor units contracting. So the entire skeletal muscle did not obey all or nothing principle, zero or full principle. It showed gradations of contractions, stronger contraction. That's important point that I wanted to make. And the second one is, of course, I mentioned this word, recruitment of the motor units. You will have a graph in skeletal muscle, particularly for those who are in first year medical school. They have a graph of gradation of stimuli. Gradation of stimuli. What is the principle behind that graph? The principle that you learn from that graph is recruitment of the motor units. Recruitment of the motor units. That is, when you apply a weak stimulus, only single, let's say one motor unit was contracting. But when you apply stronger stimulus, more motor units were recruited into the process of contraction. So 3 plus 3, 6 fibers contracting. Obviously, then the contraction will be stronger. And then when all motor units are contracting, that will be with the maximal stimulus. There will be maximal strength of contraction of that muscle. Let me just write it here. All motor units were recruited. Well, the principle was recruitment of the motor units. When you applied maximal stimulus, all motor units were recruited. That is strongest possible muscle contraction. If you increase the stimulus strength further, the strength of contraction cannot increase any further. Why? Because all motor units were already into contraction. So further stronger stimulus cannot increase the strength of contraction any further. Muscle has only these many fibers, these many motor units. So that's the second thing I wanted to mention. And the third one is, now this is little debatable, but you must have read that sarcomere is the structural and functional unit for a muscle. Structural, fine. Sarcomere is the structural unit, smallest unit where the actin-myosin interaction is taking place. What about the functional unit of the muscle? Well, the teachers will tell you sarcomere is the structural and functional unit for a skeletal muscle. Smallest unit where changes are happening. I beg to differ. Motor unit should be called as the functional unit for skeletal muscle or for a muscle. Why? The reason is, what is the function of a muscle? Muscle contraction. What is the purpose of that? Generation of strength in the muscle, generation of tension in the muscle, which is transmitted to the tendon, and then there is movement of particular joint. But a particular joint is moved. That's the ultimate purpose of the skeletal muscle contraction. Performing some work done can be calculated. So if that is the function of a skeletal muscle, in that case, when muscle is contracting, what is the smallest unit that is functioning? That is motor unit. When muscle is contracting, any muscle is contracting, at least one single motor unit is contracting. At least, the smallest unit where that change is happening and the purpose is being served is the motor unit. And therefore, in my opinion, structural unit for a muscle is sarcomere, fine, but functional unit for a muscle should be motor unit. The smallest unit where the function is being performed and the purpose is being served. So that's all for the motor unit. Next, we will discuss the sensory unit as well.